Okay, this is the exterior angle theorem. This was what we learned in class Monday, November 26th, 2018. Okay. So let's start with our triangle. We know that the measure of the three interior angles of the triangle are going to add up to 180 degrees. So here are our three interior angles. So we know the measure of these angles by the triangle sum theorem. We know the measure of the three interior angles is going to add up to 180 degrees. Okay, so measure of angle CAB plus the measure of angle ABC plus the measure of angle BCA is going to equal 180 degrees. The three interior angles add up to 180 degrees. That was what the triangle sum theorem told us. The other relationship we have here between these two angles, angle ACD and angle BCA, form a linear pair. We know linear pairs are supplementary, so we know the measure of these two angles is going to add up to 180 degrees. So the measure of angle ACD plus the measure of angle BCA is going to equal 180 degrees. Okay. Sum of the interior angles of the triangle add up to 180 degrees. Linear pair, so these two angles also add up to 180 degrees. So let's look and see what these two equations have in common. They have 180 degrees in common, and they have the measure of angle BCA in common. So let's move the measure of angle BCA to the other side in both equations. So we want to subtract the measure of angle BCA from both sides in both equations. Okay. So that's going to leave us the measure of angle CAB plus the measure of angle ABC is going to equal 180 degrees minus the measure of angle BCA. And then we have the measure of angle ACD equals 180 minus the measure of angle BCA. Right, these cross off. So that's what we have left. We notice both equations equal 180 minus the measure of angle BCA. So we can either use the transitive property of equality, or we can use substitution. We can substitute in the measure of angle ACD for 180 minus BCA, the measure of angle BCA, because that's what it's equal to. So we can substitute it in here. Or by the transitive property, since they both equal the same thing, we can set them equal to each other. So if they're equal to the same thing, they're equal to each other. So we have the measure of angle ACD is equal to the measure of angle CAB plus the measure of angle ABC. And that is what our exterior angle theorem tells us. Okay, the measure of angle ACD, which is this angle right here, this is our exterior angle, is going to equal the measure of angle CAB plus the measure of angle ABC. So this angle is going to equal these two angles added together. And that makes sense because if this angle plus this angle is 180, and these two plus this one's 180, they're both missing this one piece. So it makes sense that both of them are going to equal each other. These two are missing angle BCA. The linear pair here is missing BCA. So since BCA is congruent to BCA, right, the measure of BCA is equal to the measure of BCA, it makes sense that these two would add together for our exterior angle. So this is what the exterior angle theorem says. The exterior angle is going to equal the two opposite interior angles added together. And this is going to be true for all of our possible exterior angles. Okay, so we said and mentioned we have 3 interior angles. Okay, but we can have 6 possible exterior angles. So this one, right, A, C, D. We could also have this as an exterior angle. Okay, we could also have this as an exterior angle, or that as an exterior angle, and then we could have 5 and 6 would come from these down here. Okay, so 6 possible exterior angles. Each exterior angle is going to be equal, the measure is going to be equal to the measure of the 2 opposite interior angles added together. So if this was our exterior angle, we would have to add these 2 interior angles together, the measure of those angles to get the exterior angle. We were trying to add this one together, right? The 2 opposite interior angles would be these 2. So opposite 2 interior angles added together is going to give us the same measure as our exterior angle. Okay. So that's the theory. Okay, and this is the general form for the proof. So in Euclidean geometry, this is always going to be true. The exterior angle is going to equal the opposite 2 interior angles added together. Okay, so for examples, so we are looking for, I don't know if you can, yep. We're looking for the measure of DFG. So we're looking for this angle down here. So the measure of the angle DFG is going to equal the opposite 2 interior angles. So the measure of angle D plus the measure of angle E. Okay. We can just use the D and the E because there's nothing else attached. There's no other rays or segments or lines that go through point D. It's just this angle and only this angle. But if you wanted for it to be thorough, we could have called it angle FDE, and the measure of angle DEF. Okay, but since there's nothing else there, right, F, you have 2 different angles. So if I said angle F, you don't know what I'm talking about. Okay, but since it's D and E, and there's nothing else there, we know what you're talking about when you say angle D or angle E. So we can use the vertex and only the vertex to name those angles if we want to. Okay, DFG, we don't know. That's what we're trying to find. We know the measure of angle D is 24. We know the measure of angle E is 34. So the measure of angle DFG is going to be 58. If you wanted to, you didn't need to use the exterior angle theorem. You could have used the triangle sum theorem. Right? You know these 3 angles have to add up to 180, so we could have done 180 minus 58 because we know these add to 58. We would have gotten 122. Okay, and then we could have done 180 minus 122 and gotten 58. But that just adds extra steps. And it can be more difficult on certain problems. It's easier just to use the exterior angle theorem for triangles. These 2 added together gives us 58. Second example. So the measure of angle MKL. Right, this is what the exterior angle theorem tells us is going to equal the measure of angle M plus the measure of angle L. Okay, the measure of angle MKL is what we're looking for. Right, find the measure. Oh, we're finding X. I lied. Okay, we know the measure of MKL is 146. Okay, the measure of angle M is X. And the measure of angle L is 77. So we subtract 77. Right, 23 plus 46 is 49, 59, 69. It's going to be X. We wanted to check and double check to see if that was right. right? These form a linear pair, so this is going to be 34 because 180 minus 146 is 34, and then 34 plus 77 plus 69 should give us 180 degrees. That's 81, 91, 100, 111 plus 69 is 180. So we definitely did the problem right. Okay. 2 more examples. Our exterior angle is angle MED. So the measure of angle MED is going to equal the measure of angle, 2 opposite interior angles, EDC plus the measure of angle DCE. Okay, these 2 angles. Okay, we know the measure of angle MED is 11x minus 10. Okay, we know the measure of angle EDC is 39. We know the measure of angle DCE is 6x plus 11. Okay, combine like terms. So 11x minus 10 is going to equal 6x plus 50. Add 10 to both sides. 11x is going to equal 6x plus 60. Okay. Minus 6x from both sides. We get 5x equals 60. Divide both sides by 5, x is going to be 12. I don't think this problem asks us to do anything, but if it said find x, it's 12. If it said find the exterior angle, you would have to substitute it in. 11 times 12 minus 10. 11 times 12 is 132. Minus 10 gives us 122. If they wanted this angle, again, it would be 6 times 12 plus 11. So that's 72 plus 11, which is 83. Okay. If we want to check our answer, let's find this angle, so linear pair. So this is going to be 58. 58 plus 39 plus 83 had better be 180. That's going to be 97 plus 83 is going to be 180, so we know we have it right. Okay, one more example. If you need it. Was that last one? I didn't even look. Did we see all the last one on the? I'm sorry. We can see all this. Again, our exterior angle is 10x plus 2, and that's going to equal 2x plus 1 plus 89. Okay, if we want to be thorough, we want to write our angles in. So the measure of angle FED equals the measure of angle EFG plus the measure of angle FGE. Okay, FED E is the vertex. E, F, G, F is the vertex. F, G, E, G is the vertex. Okay, and then I have this backwards. So it'd be 89 plus 2x plus 1. So combine like terms, 10x plus 2, 90 plus 2x. Minus 2x from both sides. 8x plus 2 equals 90. Minus 2 from both sides, 8x equals 88. Divide by 8, x is going to be 11. If they're asking for x, if they're asking for the angles, we have to substitute it in. 10 times 11 plus 2. So 111 plus 2, 113. Okay, 2 times 11 plus 1, it's going to be 23. If we want to check our answer, let's find what that missing angle is. So if we do linear pair, 180 minus 113 is going to give us 67. Right? It does look like we did something wrong, which is why you should check your answer, because this is going to give us 179. Okay, so we have to go back and see where our mistake was. 8x, 88, x is 11. Two times 11 is 22, plus 1 is 23. 10 times 11 is 110. 110 plus 2 is 112, which means this is going to be 68. Which is why you guys should use your calculators, use the resources. Okay, so then we can check our answer, and now we know it works. 68 plus 23 is 91. 91 plus 89 is 180. Okay, that's the exterior angle theorem for Monday, November 26th.